Hey everybody, it's Mr. Oaks. So today we're going to talk about solving equations where we have the variables on two sides of the equation. So it's on both sides of the equal sign. As is always the case with an equation, we're trying to get the variable on one side of the equal sign and the constant on the other side, the numbers on the other side. So when we have variables on the other side, on either side of the equal sign, we have to try to move one of them to get to the other side. And usually what I suggest is to move the smaller of the two equations, of the two variables, to the other side. So if they're both positive, we know that the smaller number is going to go to the other side. If one's positive and one's negative, the negative is always going to be moved, just about. When it's negative, we always got to remember the larger the negative number, the smaller it actually is, so that's what's going to get moved. Our goal in general is to try to have it where we have a positive coefficient in front of the x, so that it's just a little bit easier to do our division. It's not a problem if we do have a negative in front of our variable, but most of the times we feel more comfortable if it's positive. It's a gut thing. You're just like, oh, it's positive, I can deal with that. Whereas a negative, some people get nervous, even though really it's not that much different. So I'm going to start off with an easy one. 5x minus 2 equals 3x plus 4. Now, again, what we're looking for is to move the smaller of the two variables. So when we look at this, we're going to look at the variables first. We have 5x on the left-hand side of the equal sign. We have 3x on the right-hand side. And so when I look at this, I go, well, which one has the smaller coefficient? Now when we look at this, obviously it's 3, the 3x. So what we're going to do is we do the opposite. So I see that this is a positive 3, so I'm going to put a negative 3, or I'm going to subtract 3x from both sides of the equation. So minus 3x underneath the 3x, minus 3x on the side with the 5x. That's going to cancel out. And what we will have on the right-hand side when we do 5x minus 3x is we will have 2x, bring down the minus 2, equals 4. What we will then do is start moving numbers off of the same side as the variable. So since the variable's on the left-hand side, it's going to stay on the left-hand side. So any numbers that are being added or subtracted from that, we're going to move first. We're subtracting 2. Opposite of subtracting 2 is adding 2. So we're going to add 2 to both sides of the equal sign. That cancels out. We now have just 2x on the left-hand side. And on the right-hand side, 4 plus 2 gives us 6. And now it's just a simple case of dividing, getting rid of that coefficient. So we have a 2 times x here, so we're going to divide both sides by 2. Again, that cancels out, and we are left with x equals 6 divided by 2 is 3. Now it's a good idea to always go back and check your work. I don't have a lot of room here, but you could always use your calculator to do a quick check. I have my trusty TI-30XS multi-view. I can just quickly go in here. 5 times 3 minus 2 is 13. 3 times 3 plus 4, also 13. What's nice with this calculator is I can see both things right on the screen there. So I know that my answer is correct. The next one, a little bit different. This time I have 16 minus 2x equals 5x plus 9. In this case, I have here, I'm subtracting 2x. I have a negative coefficient in front of my variable. I have to take into account that minus and treat it like it's a negative. So again, I have an x term or a variable term on the left-hand side, and I have a variable term on the right-hand side. When I look at this, I say, which one is smaller, negative 2x or 5x? Negative is always less than a positive, no matter how big the number looks. So I'm going to add 2x to both sides, because again, I'm doing the opposite of whatever is here. This is a minus 2x, so I'm going to do plus 2x on both sides. Plus 2x, plus 2x. That cancels out on this side. And all we have left is 16 on the left-hand side. On the right-hand side, 5x plus 2x gives me a 7x, 5 plus 2, plus 9. Again, we need to move any adding or subtracting that's on the same side as the variable away. Our variable is now on the right-hand side, so that plus 9 has to go away. Opposite of a plus 9, minus 9. I do it underneath the 9. I also need to do it to the 16. Remember, in order to keep our equation balanced, we need to do the same operation to both sides. So, if that cancels out, 16 minus 9 is 7. These 9's canceled out, so all we're left with is 7x. And now we have just a nice simple one step, 7x equals 7, or 7 equals 7x. We're multiplying, so we need to divide by the number that's in front of the variable, 7. It just happens to be the same number on the other side. These cancel out, and we are left with x equals 1. Again, I could plug this into my calculator and see, does it work? And that could be my check. Usually you're going to want to write out a check so you can see it. You know, your teachers in general are going to want to see that check, want to see the work, see the proof that it actually is correct. But if you just have to get the answer, you can do a quick check on your calculator. So of course things have to get more difficult. Why would they stay easy? I have here a fractional equation that involves fractions on both sides. A lot of fractions. 5 over 3x plus 1 over 3x equals 13 1/3 plus 8 over 3x. A lot of stuff going on there. And actually, before I even start doing anything, the first thing I'm going to do is, I don't like this mixed number. I'm getting rid of it. I'm not really getting rid of it, I'm going to change it to an improper fraction. So what I'm going to do is, okay, I'm going to keep 5 over 3x plus 1 over 3x. And now I have to change that 13 1/3. Remember, what I'm going to do is I'm going to multiply the denominator by the unit number, so 3 times 13, and add to my numerator. 3 times 13 is 39, plus 1 is 40. And I'm going to keep my denominator of 3. Plus 8 over 3x. As I always said, I don't really like to work with the fractions. I mean, I'm a math guy, so I can, but I don't like doing that. So I usually want to change this. My preferred method is to do what's called eliminate the denominator. So what I'm going to do is I'm going to look at the denominator, and in this case we have the same denominator all across. It's a 3. If I had different denominators, I need to get and find the least common denominator, the least common multiple, in order to do the elimination. But since I have the same denominator, I'm going to multiply everything by 3. And what that's going to do is it's going to get rid of all the denominators. And really, I'm just going to wind up keeping the numerators. So I'm going to multiply everything by 3, and what's going to happen is this 3 disappears. I'm now left with 5x. This 3 disappears. I'm keeping the 1, so that's 1x. The 3 under the 40 disappears, so now I'm just left with 40. And the 3 under the 8 disappears, so I'm left with 8x. I have like terms on the same side of the equal sign, here and here. So I'm going to add those two together. 6x equals 40 plus 8x. Now, this is one of those cases where even though I would normally move the smaller of the two, what's going to happen is I'm going to wind up with a 0 on this side, and I'm going to have to kind of take an extra step anyway. So because the 6x is already completely by itself, in this case I'm actually going to move the 8x, even though it's bigger than the 6x. I'm going to wind up with a negative coefficient, but that's okay, I can work with that. Okay? So in this case I'm going to subtract 8x from both sides. 6x minus 8x, I'm subtracting more than I actually have, so I'm going to get a negative answer, and that's going to be negative 2x equals 40. And then we're going to divide by negative 2. You have to remember the negative. Alright, a lot of people like to just get rid of the negative thinking it's not important. It is important. We can't ignore the negative when we're doing math. Divide by negative 2 on both sides. Our negative 2's cancel out. And we are left with x equals, I have a positive divided by a negative, so my answer is going to be negative. 40 divided by 2 gives me a 20. This one, again, we could put in our calculator to do a check. The fractions do make it a little bit more difficult, but it's not too bad. Okay? Lastly, decimals. Decimals, again, are not too bad to work with. You just have to pay attention to what you're doing. Okay? Don't let that decimal throw you off. As long as you are lining things up the way you're supposed to, you should be able to get things, you should be able to solve these no problem. Okay? So again, 5.3x plus 9 equals 2.3, oh I put a g, I meant to put an x. That's an x. If it's two different variables, I can't solve it, I'm done. But that's not what I meant to do this time. Okay? So 5.3x plus 9 equals 2.3x plus 15. So what I'm going to do is I'm going to go and say which one's smaller, 5.3 or 2.3. And now obviously 2.3 is smaller, so I'm going to subtract 2.3x from both sides. 5.3 minus 2.3, we actually wind up with just 3x plus 9 equals, the only thing left on this side is a 15. And then we just continue through our steps like we normally would. 3x plus 9 equals 15. I need to move any addition or subtraction first. So that 9 has to go. Since we're adding 9, I need to subtract 9 from both sides. Minus 9, minus 9. My 9's cross out. I get 3x equals 6. Multiplying by 3, so I have to divide both sides by 3. My 3's cancel out here. X equals 2. Again, I plug this into my calculator, I see that it works. I hope this was helpful. If you need help, you could always leave a message in the comments. Please like and subscribe, and I will see you next time. Bye.